Hello, my name is Morgan O'Connell. I am a chemistry major. The title of this presentation is Chemical-Related Filtration Techniques, Chemical-Related Processes for Filtering Water and Effective Filtration Techniques. Three wastewater filtration techniques that will be looked at is ozonation, chlorination, and ultraviolet filtration. What step are these techniques in the purification process? They are the secondary purification technique, the primary purification technique is used to get rid of bulk contaminants. Some things to consider when choosing a technique filtration is the range of contaminants the technique can get rid of, what contaminants are still left after the filtration step technique, and what is the price, but that's not as important in considering the effectiveness of a filtration technique, so that won't be looked at. So UV filtration, how does it work? So UV filtration takes a light deuterium lamp and it or tungsten, and it goes to the sample or the contaminant, and it excites a unpaired electron to the next orbital, and by doing so, for the filtration, it actually can break a bond and render a molecule inactive, such as thymine, which is used in DNA sequence. When its electron is excited, it breaks and it's no longer in the DNA sequence. And so that's how it works for diseases, bacteria, and viruses. Next is ozonation. So ozonation destructs a cell and it breaks apart a double bond. So ozonation reacts with a double bond to form an intermediate, and then it breaks that apart. So it renders that inactive and it no longer works the same. Chlorination is the same, technically the same. It attaches and then breaks these bonds apart, and the molecule is no longer there, so it's inactive. Chlorine also has free residual chlorine left, so that is available for continuous disinfection, which is different than regular ozonation. So today we will look at micropollutants. They are contaminants. They include caffeine, personal care products, pharmaceuticals, and we will look at two studies that analyze the effectiveness of these techniques and combinations of techniques to get rid of micropollutants. The first study is Han River in Seoul, Korea. The techniques is ozonation, UV and hydrogen peroxide, and UV and chlorination. The analysis technique used is liquid chromatography coupled with mass spec. Liquid chromatography is a separation technique that separates the molecules based on diffusion, polarity, and acidity. It offers a high resolution and can detect concentrations as low as parts per million. MALDI is a detector, and it fragments molecules with a laser, and that helps determine a structure. So the results is the UV and chlorine process combined specifically gets rid of greater than 90% of metoprolol, which is a pharmaceutical that they found in surface and drinking water in the Han River. This is because UV chlorine process can produce both chlorine and hydroxyl radicals. The second study looked at a river in Spain. It's from a Spanish drinking water plant. Has pre and post chlorination as well as ozonation. This is their scheme with pre-chlorination, ozone, and post-chlorination. It uses the same high-performance liquid chromatography, which is just a greater pressure, which gives parts per billion detection instead of parts per million, and uses electron spray ionization mass spec detector, which gives smaller molecule detection than MALDI, which was used in the last one, for very large molecules. Results is pre-chlorination removed a lot of the nicotine, cotinine, caffeine, cocaine, and benzoglycanine. And you can pause and look at the percentages. Ozonation was found to remove caffeine most efficiently by 76%, nicotine, and only removed small amounts of cocaine and benzoglycanine and the nicotine. And this is probably because cocaine and benzoglycanine have very few sites for the ozone to interact with, and which is why they're probably not removed as efficiently. Conclusion is that UV chlorination and ozonation are efficient at removing contaminants found in a river. UV and filtration is probably one of the best because it doesn't need sites to break apart, but it is more expensive, which is a reason why not many people use it. And in the future, I hope that there is different purification techniques that can be used where you don't have to have readily reactive sites.